Hello, hello, hello. Welcome to AP Environmental Science, Unit 9, the final unit. Do-do-do-do, do-do-do-do-do, do-do-do-do. It's the final note sections. I apologize. Profoundly apologize. All right, so for Unit 9, we're going to be covering a variety of topics, and I will begin those topics by giving you an outline of the 10 topics. There will not be 10 videos. There will be more than 10 videos because I plan to break the longer videos up so it's a little more manageable for your time. So keep in mind that the videos in this series for this unit will not match up perfectly with the sections. Some of them they will, others will not, just because of the way that I'm going to try and make this a fairly digestible unit. So we're going to start with stratospheric ozone depletion and reducing ozone depletion, which should not be topics that we have to spend too much time on because we did, in fact, go over those back in Unit 7. So we will touch them, but we won't go in too much depth. If you feel like you need a little more information on those, come see me. Maybe you missed when we did that in class. Then we'll talk about the greenhouse effect and the increases in the greenhouse gases. Then we will hit global climate change, related with global climate change, of course, ocean warming, ocean acidification, and then we will discuss a little more into invasive and endangered species, which again, we talked about way back in Unit 1 or 2, and human impacts on biodiversity, which we have been talking about not only from Unit 1 and 2, but also throughout this entire course. So that should be, it's a nice lengthy discussion about those impacts just to remind us of all those things, but these are not new topics completely. Alrighty, so let's get started on 9.1. Stratospheric ozone depletion. So there's the haircuts that nearly destroyed the ozone layer because aerosols, right? We talk a lot about aerosols and how they were pivotal in depleting the ozone in the stratosphere. So what's the difference between good ozone and bad ozone? Hopefully you guys remember that the good ozone exists in the stratosphere, right at the top of the stratosphere, protects us from UV radiation, and the bad ozone would be that stuff in the troposphere, also referred to as photochemical smog. So good ozone versus bad ozone. So remember, ozone in the troposphere is bad, ozone in the stratosphere is good. And you can hear my cat, which means I'm going to let him in so he'll shut up. Come on. He's probably going to say hello again. All right. So the protective layer in the atmosphere is the good stuff, the ground level photochemical oxidant, where you have sunlight reacting with VOX and NOx, not SO2. Not sure why that's there, sorry. All right, so protective ozone, again, helps to protect us from UV radiation. The ozone can actually absorb the UV rays, which allows just enough for life on Earth. That is what the ozone layer does for us. So how does the ozone layer form? Well, it's pretty straightforward. Oxygen and ultraviolet rays combine to break that oxygen molecule into atomic oxygen, single oxygen atoms. Those single oxygen atoms are then able to bond with an oxygen molecule, forming that beautiful O3. So O2 plus UVC combines to make O plus O. That O combines with O2 to make O3. So CFCs are what we're using, or what we refer to as these things that are depleting or were depleting the ozone layer. Okay, so what are CFCs? Well, they're called chlorofluorocarbons. They can be non-toxic and non-flammable and very stable, and they have carbon, chlorine, and fluorine, hence the CFC. You find these in refrigerants, propellants like aerosols, and then foam and packing materials. They are in many different objects. So how do they break up or break down the ozone? We didn't really go into a huge amount of detail here, but this is the basics behind it, okay? UV breaks a chlorine atom from the CFC molecule, and then that free chlorine atom is able to hit an ozone molecule and break an oxygen away. It pulls an oxygen away to create a ClO. And then a free oxygen atom is able to hit the chlorine monoxide molecule. So remember that free oxygen would have tried to find an O2 to make O3, but instead it goes in and says, hey, CLO, I like that. I could steal that oxygen. And that releases that free chlorine atom back, creating an O2 molecule and allowing that free chlorine to then cycle back and deplete more ozone. So this is a positive feedback loop. The chlorofluorocarbon itself, by losing its chlorine, that chlorine is able to go through in a chain reaction and break away oxygen from O3, and then breaks off of the of that new molecule that it forms, the CLO, and then is able to do it all over again. That's why it's really bad. So one chlorine atom can actually break down 100,000 molecules of ozone before it will bond with another chlorine atom, eventually creating Cl2, which is what stops the reaction. So you need chlorine to bond with itself to stop the reaction, and it can go through 100,000 times of this process here before it finally finds another chlorine to end the cycle. So it's a catalyst. It aids in another reaction, and it's not actually getting used up. So if you remember back in chemistry, it's the thing that speeds up a reaction, the catalyst. That's what chlorine does, okay? So the hole in the ozone layer is the thing that we think about when we hear, there's a hole in the ozone layer. Well, in the mid-'80s, they noticed that there was a serious, severe thinning of the layer of ozone over Antarctica. And we talked a little bit about this. The main reason that it happens over Antarctica is because there is a lot more free ice molecules in the atmosphere, which encourages the chlorine process to occur. So that is the end of 9.1. This is our first video. 7 minutes, not too bad. I'm going to try and keep them under 10 minutes, so I hope that I do. All right, make sure to check out the next video where we'll start to talk about reducing that ozone depletion.